All right, I now want to introduce to you someone from HPE, Hewlett Packard Enterprise, that has helped make today possible. And Denise Wilsey, and come on up, and she is business development, and she is the one that has taken the lead on our ATSC3 services here and making a lot of this possible. So, yeah, go ahead.
Thank you, Lee. My name is Denise Wilsey. I'm Director of Sales and Business Development at Hewlett Packard Enterprise. But what I really want you to know about me, and I'll try not to get emotional, is this is the first time in my 26-year career I've had the opportunity to have what I'm representing from a solutions and technology perspective impact my life so personally, and that is my faith. And so I just thank you all for having us here. I hope you'll appreciate where we're going with this, and we look forward to, after this ceremony, just having some opportunity maybe to converse a little bit further. So with that, I am very excited to tell you about what we're doing together, HPE and ARK Multicasting. We started this journey about 1.5 years ago, and it has been an absolute wild ride the entire time. We are on the cutting edge and innovating in real time. We are making history leveraging the new opportunities that ATSC 3.0 enables. HPE has always been a company of innovation from the very inception of Hewlett Packard to today. It's a story that has points all throughout its history of innovation. And so we gravitate toward companies and those that innovate. And what we have seen with ARK is an opportunity to bring the market something that's never been done before, demonstrate new revenue opportunities that have never existed, and serve public with services that have never been possible before. So when ARK came to HPE and talked about the business model they're building around Datacasting, it was an absolute perfect fit. I mean, HPE, we can leverage what we're already doing in the telco and the cable space and some enterprise sectors. And what that means in the broadcast world is where it's the process of moving your physical environments, virtualizing your stations at the edge to the cloud, which is enabling great efficiencies that have not been possible ever before. And by orchestrating ARK's information and the data traffic, we enable and empower ARK to provide their services to their end customers in a manner that has never been available before. And so it is equally exciting to see a company like TBN, who is a giant in the broadcast space, partner with ARK and embrace the opportunities with ATSC 3.0. They're a broadcast ministry of innovation. TBN recognizes the value of the broadcast spectrum beyond what has traditionally been used for. Again, it's an endorsement for what ARK is doing with their network of stations and spectrum. And I'm excited for you all to hear tonight from ATSC, TBN, and ARK. We have a demo planned, which I think you'll find interesting. What I really hope you take away from tonight, though, is that you recognize the leadership that's being demonstrated here. We together can empower your stations, your ministry, and help you innovate to continue to spread your message. So I thank you all for being here, and I hope you enjoyed tonight's program.
And thank you, Denise. Again, I want to thank ARK, HPE, and TBN for being such trailblazers in the new technology of ATSC 3.0 and the television spectrum. And I want to tell you a little bit about the ATBA as well, the Advanced Television Broadcasting Alliance. That organization actually formed after the CBA, an organization that helped out LPTV, or was the LPTV Association dissolved, and we realized that we did not have a representation in the low-power television industry. And with the spectrum auction coming up, we were very, very afraid of losing television spectrum. So right outside those doors, Club 44 used to be there by the rail, a group of folks, men and women, got together and formed what was first named I wrote it down, guys, Coalition for Free TV and Broadband. And we used that name for a year till we became the Advanced Television Broadcasting Alliance. And so that organization has fought on the Hill to save spectrum, and we're proud today to be able to help our industry, the low-power TV industry, lead the way, or help lead the way in the ATSC 3.0 space. So I have another introduction to do, and that is somebody that is way smarter than me. And it's been a privilege to be a part of the ATSC 3.0 organization as the ATBA. I'm going to introduce to you Madeline Noland. She is the president of the ATSC, and that is a standards committee, I guess is what we call that. And I could read her bio for you, but we would be here all day. But I also want to give a plug for her session tomorrow on the floor is at 10 a.m., 10:15, and she is going to dive a little bit deeper into ATSC. So be sure and catch her session tomorrow. That'll be in your NRB schedule and on the app. So if you will, Madeline, come on up and give us a little word.
Hello, and thank you for having me. Thanks so much to Lee and to Josh from ARK and to Denise from HPE for inviting me to speak to everyone today. So I'd like to thank everyone for attending this Next Gen TV reception. My name is Madeline Noland. I'm president of ATSC, or the Advanced Television Systems Committee, not to be confused with the Advanced Television Broadcasting Alliance. But I've been in the television industry since the early 2000s when I joined a small company called Back Channel Media. And what we did was it was a startup company. We were focused on direct response, which many of the ministry broadcasters were very interested in. They would have long-form time that they would purchase through, sort of jobbers, if you will, and Back Channel Media was among them. But one of the things that Back Channel Media was doing was trying to bring direct response into the 21st century. Because yes, the assignment of 800 numbers in a clever way helps you track the messages and understand where your audience is coming from. But now we have digital TV. Surely we can do interactive television, right? And wouldn't that be great? That would be even better than 800 numbers. So Back Channel Media decided to join the Advanced Television Systems Committee to find out what was going on, and they assigned me to go and sit in these committee meetings and find out what's going on for the next generation of television systems. And knowing me, I can't keep my mouth shut, and so they said, well, why don't you chair this group, and why don't you do this? And then I found myself representing another company called TeleView, and then about 10 years ago, I started representing LG Electronics in the Advanced Television Systems Committee proceedings. And about 3 years ago, I was named president of ATSC. So you could say that I have been completely immersed in next-gen TV since its inception. I have been living, eating, breathing, and sleeping ATSC 3.0, aka next-gen TV. So this is my first time attending NRB. I'm so happy to be here and to share the news about ATSC 3.0. A little bit about ATSC, people are like, what is a standards development organization anyway? Well, a standards development organization is an organization that brings people together to have a consensus about what different products should be like in order that they can work together. So the example I like to use is flashlights and batteries. If you want to have Kathy's battery company, Kathy knows that batteries come this big and this wide and put out this much power because there's a standard. And if Mark wants to have Mark's flashlight company, Mark knows that the chamber needs to be this big and this wide and that this much power is going to come out of the batteries, and that's because there's a standard. Well, for television, we also have a standard so that what the broadcasters put out and what the television sets can decode and understand and display to the viewer, it all works together. And the Advanced Television Systems Committee is the place where people like Mark and the television makers and everybody from the ecosystem gets together to hammer out what this thing is going to be, because people need to agree on what the technology does so that we don't have flashlights that cost $10,000, because the battery people wanted all kinds of cool stuff, and we know we can't do that. So it's a consensus-driven organization where we build standards. ATSC is an international organization. We have members from across the broadcasting ecosystem, and they come together to develop the new technical standards for over-the-air broadcasting. We have over 150 members, including broadcast stations and networks, TV manufacturers, station equipment vendors, television tower owners, research universities, and they come from all over the globe, and I see many of them in the room today, so thank you for that. ATSC was formed 40 years ago to bring industry engineers together to design the first digital over-the-air transition from analog to digital. You guys remember converter boxes? Yes. So the system that replaced the analog system that made people who still didn't have a new TV need a converter box, ATSC wrote that system, and I can see some people in this audience who were part of that process. Mark is smiling. So the new digital TV system, new at that time, was called ATSC 1.0, and it has been in use and been very successful in the US, South Korea, Canada, Mexico, Caribbean, and some Central American companies, and it's been on the air for over 20 years, I think, is the number. But about 10 years ago, the members of ATSC foresaw that a new system would be needed in order to replace what would become a 20 or 25-year-old ATSC 1.0 system. Because a lot of new technologies had come along. There's new video compression. There's new technology to get better efficiency over the air. And so in order to remain relevant in this rapidly changing environment, ATSC members says, we're going to need to step it up. So as a result of this foresight, ATSC members started and work on ATSC 3.0, also known as Next Gen TV. Took about 9 years to get it all done, and it is done. So in 2017, it was deployed commercially in South Korea. They wanted it on the air by February 2018, by God, because of the Winter Olympics in Pyeongchang. And they got there. It's being rolled out here in the US now, and in Jamaica as well. So the new digital system, actually, and this is one of the things that's going to be coming together for you tonight, is that it's based on Internet Protocol. It is currently the world's most efficient broadcast standard, bar none. There's no other better system in the world today. And since it's the world's first IP-based broadcast system, it's actually about delivering any kind of data. So it can deliver linear television data in the traditional form, but it can also deliver any other kind of data like software or firmware updates or distance education learning materials, enhanced GPS, file-based media. I mean, in fact, it's the best over-the-air television distribution in the world and more. So the ATSC members designed this amazing new system by consensus together, and today it's in commercial use in South Korea and Jamaica and is being considered for adoption by many other nations. And here in the US, the commercial deployment started in 2020, right as the pandemic hit. And I have to say, I have to take my hats off to all the broadcasters in the room who have been launching this commercially throughout the pandemic, after the repack. I mean, there couldn't be enough things to make it harder. And now about 50% of US households can receive the new signals, and that number is expected to reach over 82% by the end of this year as broadcasters are continually launching new stations across the country on practically a weekly basis. And again, I keep looking at Mark. I have to tip my hat to Sinclair Broadcast, who I think launched a station every 2 weeks in 2021, more or less. So pretty impressive. So Lee mentioned that tomorrow at 10:15 I will be speaking on the NRB Talks Stage off in the exhibit hall, and I'll be giving a deeper dive into what ATSC 3.0 can do, how the deployment's unfolding, what's going on with television sets in the marketplace, including that nice-looking Sony TV that you guys can win. Don't forget to capture the code. And how this new system can help NRB members deliver powerful messages and connect with audiences in brand new ways. And I'll also talk about the special role that low-power television broadcasters like ARK Multicasting can play in the new ecosystem. So they actually have a unique role in the ATSC 3.0 rollout in the US. So I encourage you to join me on the talk stage tomorrow at 10:15. But today, I'm here to congratulate some of ATSC's own members who have been instrumental in developing exciting new use cases for broadcasters using ATSC 3.0. So I'd like to thank ARK Multicasting, Hewlett-Packard Enterprise, and TBN, all ATSC members, for their tremendous efforts and novel approach to this flexible new standard. And I'm personally very excited to see this demonstration because I haven't seen it yet. Nothing makes me more proud of the efforts of the ATSC membership than to see the results of the work in action. So without further delay, I think I'm going to be turning it back to Lee, and we can see what these great companies have built together. Thank you so much.
All right, so don't forget to scan the code. And speaking of the code, edge to cloud. Edge to cloud is the secret words you will need somewhere in that to win that television set. So, all right, so it's now time to get to our demonstration, and we're going to talk a little bit about Josh Wise and ARK Multicasting. ARK Multicasting has been here at NRB, so a lot of people want to know what it is. Well, it's a broadcast company using cutting-edge technology and the next generation of content delivery throughout the United States. The foundation of the business model is capacity as a service for clients wanting to efficiently get data from one point to many. So we're going to get to hear from Mr. Josh Wise, or he's almost Dr. Josh Wise, I understand. He is the co-founder and CEO of ARK Multicasting, which is the largest unencumbered broadcast internet network in the U.S., serve over 100 million people. And as you see up there on the graphic, the first 10 stations being built out as we speak. So, Josh, come on up and give us a test drive.
Well, thank you so much. I'm going to put that slide back up for you guys because I know that you don't want to miss it, right? And you're thinking, I didn't get a chance because it was scrolling so fast. So I'm going to put it back up here. It will be shipped to you, so you don't have to worry about having to fit it in the overhead compartment on the plane. You'll need to put in the secret code, though. Like, we're all about secret codes. Edge to cloud infrastructure. Edge to cloud infrastructure. And Denise didn't go into, as you can imagine, all of the things HPE could be talking about. She didn't go into the edge to cloud because we're going to be demonstrating it here in a moment. And I just want to take a moment and say it's exciting when cutting edge and innovation and being on the forefront of technology is taking place at an event like the National Religious Broadcasters. How many believe we don't have to follow? We can actually be leaders. You believe that? As Lee mentioned, the Advanced Television Broadcasting Alliance started here at the National Religious Broadcasters. And so much innovation has taken place, but I want to challenge us. We can't stop with where we've migrated to. We've seen it over and over again. I don't know who actually gets the credit, but we've all heard the phrase innovate or die. Companies need to innovate or die. And for such a long time, we as an industry in broadcast have lived with a very, very clear business model, a very clear opportunity, and we've stayed within that box because that's what we had to work with. But that box has changed, and we have to fight the desire to stay where we've always been. We need to innovate. We need to go beyond what we've done because the opportunities that are present blow the roof off of our ministry opportunity, our ability to reach the world, but it also blows the roof off of our opportunity for capitalization. I've been coming to NRB for over 20 years. I started when I was 5. And ever since I've come, I see the same stories unfold over and over again. Those stories are very consistent about ministries trying to find new ways to generate revenue, generate donors, ministries trying to find new platforms for distribution, distribution platforms trying to find new ways to gain more eyeballs, people trying to connect content owners with content platforms and distribution and service providers, but people are always looking for ways to pay the bills. And I know it's been getting more and more difficult because more and more people are migrating towards more and more options for where they get their information. Social media, streaming platforms, all of the different paid services that you might get. And so there's a greater need for the church to innovate and come up with new ways to reach people, because we've got a message that's worth reaching people with. And so I have been a part of this journey. I was born into it, obviously. I was 5 years old. And I've been coming here, I started off with my family. My father is the head of our ministry. And we produce TV. And so we started off producing TV. But I've been along this journey for the last few decades of just following the crazy directions that God leads. Because if you were to look at where we're at, it would make no sense other than somebody outside of us gave some direction for us to take steps that didn't make sense, at times that didn't make sense, to make moves that didn't make sense, to bring us to a place where now it makes sense. And it's not because we're so smart. It's because we've been on a faith journey. And that faith journey has brought us to a place of enormous opportunity, both on the financial side, but more importantly, on the opportunity to reach people. Because, like I said, I've followed this story. I've seen this movie before. We've been going down this path, and we all have a goal, right? Either on the business side or on the ministry side, we all have this same goal of reaching our publics, and we've got to pay the bills to do that. So, a little bit about ARK Multicasting. Lee mentioned it. We've got a portfolio of some 300 stations. We cover 100 million people around the country. And you might say that's pretty impressive, but these stations have never been monetized because we're really not that great, right? It was a faith journey. And God brought us to a point where we are now, and we've got this massive portfolio. And He's unveiled this opportunity that we are just so excited to participate in. And so you look at our portfolio, these stations each reach about 70 miles, give or take. That's a pretty good amount of coverage in any market. They've never been used for commercial purposes. And why is that? Why do I say that? Why does that matter? Because they've never been used for commercial purposes, there's no legacy business that limits us, that forces us to stay doing what we've always done. We can innovate in new ways without the concern of losing something because we weren't earning something. We've been using them for purpose-driven content. And guess what? We still can. That's exciting. So they cover about 70 miles, and we have an opportunity to move into this datacasting business model. And datacasting, what does that really mean? Well, as Madeline mentioned, this new standard opens up an opportunity for broadcasters to not just be linear video content providers. We don't just have to play a video and make sure we get there at the beginning of the video or pause and use a DVR to record it or record it on a DVR and watch it later. We're not appointment-based anymore, just like the rest of the world, actually. Now it's data. It's part of the IP. So we send video files just like you would see them on YouTube or Google. We send video files or data files just like you would see if you're using your Xbox and you need to download a file. We're sending data files just like if you're needing to do a firmware update in your vehicle or any other form of data. We're able to participate in that space, as well as linear video, which is an exciting thing. So we see opportunities to serve customers in the over-the-top world, which is your streaming providers like PureFlix, who I see out there, We're able to serve customers in the internet service provider space because the existing networks are so congested. When I speak to ISPs, I hear something very, very scary. When Xbox does a gaming update, that gaming update is some 75 to 100 gigs, and that's happening multiple times a month. When that 100 gig file goes out, it's not just going out one time. Every single Xbox in the city that downloads that 100 gig file is using 100 gigs of data. So if 1 million Xbox users in a market use that Xbox update, 100 million gigabytes go across the network. That's a scary issue with this unicast world we live in. And so the ISPs will tell us that when an Xbox update comes out, their network is congested 65% with that one file because it's going out over and over and over and over and over again. Well, I could send it out once, and all 6 million people in my Dallas footprint, if they have that ability to receive it, I could update all of them at one time. So instead of 100 gigs replicated by each user, it's one time. So imagine the opportunity I have to monetize that one time I send that, and I can still do everything I'm already doing on the ministry side. That's an exciting proposition. And it doesn't end there. I'm helping the ISP, but I can also serve distance learning. How many of us saw the COVID stories? Everybody's, I know, I hate online learning. And I'm an expert at doing that, unfortunately. Online learning is a difficult thing to begin with, and you know how much more difficult it is if you don't have connectivity? Well, 50% of our US does not have broadband. And even in markets where good connectivity exists, students are struggling. You're going to hear from Larry Haley here in a few minutes about some of the innovation of what Trinity Broadcasting Network and Trilogy 5G are doing. And one of the really exciting things is the Dallas Independent School District. Sorry if I stole your thunder. Dallas Independent School District. They've got connectivity in Dallas, but they're interested in this because it answers a need, and those bits can be monetized. And I could go on, but I don't want to take too much time. The connected car market, every time Ford wants to update that F-150, it's a cost. And if people don't bring that vehicle to the dealer, it's potentially dangerous depending on what that update is. As cars start to drive themselves, how are they going to get from point A to point B if connectivity isn't great? It's a very dangerous proposition without good connectivity. Smart agriculture, cloud, CDN. We could serve Amazon, we can serve Akamai, we can serve Google. Any cloud provider can utilize our service. So I'm just trying to help you wrap your head around the opportunity that exists if we're just willing to step out, to just try it and see what's out there. I believe God gave us direction, and that's why we are where we are. That's why we're able to take steps of faith, because we're not so concerned about what it means on the other side, because we're just being obedient. So the opportunities that you see, they're endless. And just to give you one more slide, I won't go into too much. I say that one more slide. I'm also a pastor, so you should know, right? Like in conclusion. But we will be getting to the demo. This isn't the functional demo. You're going to actually see the bits flowing through, and I'm going to show you how we actually will do this with multiple customers. This is going to be exciting. So Verizon, in 1 month during COVID, 218,000 terabytes. That's in one day, March 23rd. That works out to 6.5 exabytes. You might not even know what an exabyte is. So 1,000 gigabytes, and then that makes a terabyte. 1,000 terabytes makes a petabyte. 1,000 petabytes makes an exabyte. 218,000, that works out to 6.5 exabytes. That's nationwide on a unicast one-to-one network. Think about that data consumption. The average household consume 650 gigabytes every single month. In our Dallas station alone, we'll just use a round number of 6 million people. We actually cover more than that, but we'll say 6 million people. At 24 megabits per second, which is about the data throughput if we're using certain settings that were, so 25 megabits per second, that works out to 7,500 gigabytes per month, per person. Think about that. 7,500 gigabytes per month per person. You multiply that out by 6 million people, you have 45 exabytes in 1 month in one city that we're capable of transmitting in a nation that is consuming data at alarming rates with networks that cannot sustain those alarming rates. There is no other solution as efficient, as effective, as elegant as what we're bringing to market. That's exciting. So where are we at? So we've got 10 stations. You can see on the map here, there's only 9 dots because we've got 2 of those, 2 stations in Panama City. These are the first 10 stations we're deploying, and we have, they're all in different stages. They should be all up and completed within the next 30 to 45 days. Dallas was lit up just 2 weeks ago. Very, very exciting. You add on to that the rest of our portfolio, and you see the 300 stations. But I want to talk about TBN a little bit because you add TBN into the mix, and now you put us up to 215 million different people in the U.S., 1.7 billion megahertz pops. The cellular world looks at the value of spectrum in terms of megahertz pops. How many megahertz do you have? Well, in a broadcast asset, we have 6 megahertz. So 1.7 billion megahertz pops. Think of what is possible. So I'm super excited about where we're at. I'm really excited about TBN's willingness to innovate. They've always been a company of innovation. I've met with them on several times. I've got a deep respect for Matt as he shares the history of TBN and all that they've done over the years. They were the first ones that really pushed satellite. You know, their engagement with satellite and the cable side of things, they've done things in an innovative way throughout their existence. And that apparently hasn't stopped. And so TBN is ARK's first customer. We're very excited about this relationship, and we're excited about what they're doing because they're not leaving it at linear video. They've got a lot of opportunity and options and thoughts of how they're going to handle the bits, the data, through this new opportunity, this pipe that we've created. And so you're going to hear a moment. I'd actually like to bring up Larry Haley. Larry Haley is he's been on the backside of TBN's engineering and their broadcast side for a very long time. Larry is I get in the room, I talk with Larry, I feel a little bit smaller every time because this guy's a super smart guy, and which is why I'm going to give him the mic now. Larry is the CEO of Trilogy 5G, which is a wholly owned subsidiary of TBN. So Larry Haley, will you come on up and share a little bit about TBN and Trilogy 5G? By the way, edge to cloud infrastructure.
Well, thanks everybody. I appreciate everybody being here. Obviously you're getting plenty of technical detail from everybody else, and obviously with the demonstration later. I wanted to share more kind of the why that TBN is involved in the way we are and what we're thinking. So obviously as any other ministry, unfortunately, as Josh alluded to, there's always a concern about revenue. You're always looking for other opportunities. So about 3 years ago, as we were researching different things, we started exploring what options there were to monetize our spectrum differently. Were there other opportunities that we weren't aware of? Obviously, post the repack auction, there were a lot of thoughts about what the value of that spectrum was, but what could you do with it after the auction? The interesting part behind this is that I have to admit this, unfortunately. 6 years ago, when I came back to TBN, I was asked to provide a report to the executive team on ATSC3 and how we felt TBN should be involved and everything like that. And the synopsis of my report was, if somebody hadn't invented the internet, this would be a really cool idea. I unfortunately, at the time, did not have enough information, had not seen enough to really, truly get it. I'm happy to say now I do. I tell you this story more to help you understand. I haven't drank the Kool-Aid. I'm not up here trying to sell you something. This is something I have been convinced of and have learned through what we have done and seen the opportunities that we can bring not only to our ministry, but all the other ministries, all the other faith-based broadcasters, and how we can do that. So as we decided this was the path we wanted to go down, we started an R&D initiative, which has morphed into our for-profit company, Trilogy 5G. When we started that, we built a full-up RF lab at our Irving, Texas facility. We not only had broadcast engineers, but we hired several very good engineers from the wireless industry, tried to bring as many different disciplines into the project to understand what the possibilities were. We wanted to look outside of, we understood the capabilities of ATSC3 and the different tools that were built into it, but we felt like there could be more. Whether with the spectrum itself or bonding it with other available spectrums that were, newly available to be used in different ways. So we brought just about every piece of wireless equipment you can imagine between wireless providers and broadcasters and everything into the lab to see what it could or couldn't do. Can we break it? Do they play well together? Do they not? And learned a lot in a hurry. And the takeaways, to not get into a very deep technical piece of this is, and this is the type of thing as a ministry that you want to understand, is that because of the efficiencies of the new protocol that Madeline spoke of and things like that, that we discovered that we could continue the same amount of linear channels that we have now with our multicast. Same quality, same capability, same reach. But when we got done, we had 50% of our spectrum left over that we weren't using. 50% that could be monetized in other ways. And that was exciting to see that we had that capability, that RF real estate suddenly had more room than we thought it did. Build a second floor on, whatever you want to call it, it was there. We had the capabilities. So it worked well. We started finding more and more partners. Obviously, that was when we met Josh and his team from ARK and what they were doing, the innovations that they were already pushing for. HPE, several other folks that we've brought to the table have in our lab, have actually tested this. The same demonstration that you're going to see here, we have running. We didn't just trust other people. We did the same thing again, double blind test type of thing. Yeah, we know what salespeople can tell you or this, that, and the other, but does it really work? It does. We've done it. We have probably over a dozen different set-top boxes in our lab right now. How can you get the data home? How can you interact with people? How do you use the tools that are available? That's what we're doing now. We're happy that we're able to be the one blazing the trail or helping other faith-based broadcasters so that we can all grow together, that we can all find these capabilities together with that unused bandwidth. So obviously, Josh has already spoken to some of the different use cases. So there's a lot of really interesting stuff, to not get too much into the weeds, but I know any of you that have seen the articles or not, just recently there was a test done, I believe it was at North Carolina, where they used the 3.0 capabilities to provide information to first responders. Where this becomes critical is that we have the ability to provide up-to-date real-time information to first responders in emergency situations, non-emergency, whatever, that they're not reliant on a cellular backbone. They're not reliant on, is there enough throughput in the middle of an emergency? Is this working, that working? That we can get that to them real time on a regular basis. And as one use case, you can morph that into utilities. We've actually had meetings with engineering firms that are dealing with the utility industry, and they see the ability to do the same thing with the support trucks for the utilities, that we can provide real-time information to these trucks, whether it's their day-to-day operations or even more so, just as broadcasters have always been serving the public good, that during emergencies, hurricanes, things like that, that we could continue to provide not only information about where the outages are, but real-time weather, different pieces like that that are useful tools for the folks in the field. That is extremely useful. And you can take that and morph it into the delivery, Amazon and UPS trucks. You can think about how many UPS trucks are running around town, and if they could get real-time data to all those trucks without having to burn the cellular data and pay for that, that's a business model you can see right now. That's not something you've got to imagine. It's already there, that there's already customers looking for opportunities, beyond the type of stuff that Josh talked about. And obviously the education piece that he alluded to with Dallas Independent Schools. This is where we have kind of gone beyond just what can be done with the spectrum with our with Trilogy 5G, is that we have invested, and because of having the staff, into doing private LTE networks. We had the opportunity, because of having a different tool to bring to the table with ATSC3, that we were allowed to participate in a proof of concept with Dallas Independent Schools, and have built out 3 schools with not only a private LTE network, but are getting ready, with ARK's help, show how that we can deliver at the same time data to all the students simultaneously, whether it's lesson plans or schedule updates, everything like that, without taxing their LTE backbone that they want to build to all the students. So that was very exciting to them, and it's a great use case that presents itself. That's the one thing that to understand about another motivation with our partnership with ARK is that, as he shows with the map that you saw a few minutes ago, the coverage is everything. Yes, you can take a single station, we can deal with a single city, we can do a Dallas Independent Schools, but if you want to talk about a national customer like a UPS or FedEx or Ford Motor Company or something like that, it's about coverage. It's about being able to provide them a national footprint. Something exciting that I would see in all of our future is the ability, no different than Sinclair and Nexstar and folks have done with Pearl TV, is that we could take, as faith-based broadcasters, do a similar consortium, a group where we're stronger together than we are independent. You don't have to get as deep as TBN has done with our Trilogy 5G and building out private LTE and everything, but if you can be part of a group that can make us all stronger and make you part of an existing system that gives us all those capabilities together and to be able to help us monetize together. I think that's very exciting thing to look at, and obviously makes good business sense because Mark and his folks have done the same thing. There's an analogy I want to give you, I guess, to kind of wrap up when we talk about a different way to bring revenue to the table. Is imagine your spectrum as your virtual church, which it is for all of us. Well, somebody's just walked up and told you there's oil underneath your church. And you can either do like TBN, you can drill the oil, transport the oil, refine it, get it to the gas station, sell it, or you can partner with ARK or us or somebody else and just have mailbox money and have the revenue from that oil show up every day with what you've got. And it's an amazing opportunity that is a great way for us to continue to expand the capabilities of delivering the message for the kingdom that we're all here to do. So, anytime somebody wants to talk or you have other questions and stuff, like I said, I didn't want to get too far in the weeds because And that's a challenge for an engineer to not want to get into the weeds, trust me. I would really like to. So, but anyway, I hope that helps give you some insight, and appreciate it. Thank you.
Well, now for the fun. And I'll apologize in advance because we are going to get into the weeds a little bit. For those of you that like to see the work being done, I'm going to give you see on my screen here, we've got several different things I'm going to show you. And we're going to have 3 different screens we're going to go through. I got to reconnect to the computer here. So we got 3 different screens that I want to show you. And so you understand, when I'm on the different screens, you ever follow you've seen the different games where they've got the little ball under the 3 cups and you move them around? Try and follow which screen we're on as best you can, because we're going to go a little deep. And so on the far left here, I've got 6 tabs at the top. This is the station side. So this is ARK, and ARK controlling ARK's station and ARK's customers. The next one in the middle here, this is the customer side. So you'll be able to see what the customer does. And the one on the far right is the end user. Remember, ARK is a B2B play, a business to business. And our customers, they have their customers. I am not trying to go to the end user. I'm going to their providers, or to the content owners, or to the CDN, the content delivery network. I'm going to other businesses, and then those businesses have their end users. So this far right screen is their customers, okay? So before I bring up our next guest who's going to go through this demo with me, because you need somebody smarter to participate, and that's going to be an engineer, solutions architect from Hewlett-Packard. You'll be seeing him in just a minute. This right here on this screen is an encoder. What's an encoder? An encoder is something that we use already in 1.0. 1.0, we've got linear video. Well, how do you get that linear video? You either have an IP stream, and then it's got to be encoded for the video signal, for the broadcast signal, or you have content coming from satellite. And so you're pulling down from satellite, you have to then encode it, and then you put it out into broadcast. That's 1.0. But we still have an encoder in 3.0. And we're actually still, in this particular demo, you're still seeing the same encoder that we use in 1.0, which is a company called ATEM. And right now, you're going to see that there's 2 channels playing on our station. This is in our Dallas location. You got 2 channels. That's TBN, their first channel, and their second channel. In a bit, you're going to see how we turn that up. The second screen here, this is where we start now stepping into 3.0. Because remember, we're no longer making this video for a linear broadcast transmission. Now it's IP. It's Internet Protocol. So you have to now switch the bits, to be Internet bits. And so that's what this route MMTP encoder is. And Treveni, I see Ralph in the room at the back. This is Treveni. Ralph is with this fine company. When you hear people in the industry talk about 3.0, the software and hardware that's doing the magic at the station level is typically called the 3.0 stack. That's kind of a common term that you'll hear used. Well, one of the things in the stack is this encoder. And you're seeing right now that there's 2 channels on my left screen. There's 2 media streams. That's TBN1 and TBN2. We're using up this 2 megabits per second because it's a more efficient service. And then over here, you've got the little thumbnails kind of refreshing. The next thing in 3.0 is that we've got to package all these things together because there's going to be data streams, there's linear streams. So that's when we get into this section, which we call the gateway. This is also a Treveni product. And what you're seeing here is how the 6 megahertz is being sliced up. The great thing about 3.0, and Madeline was very, very reserved to not go into the technical details because we can all fall asleep real quick. If I haven't already put you there, let me know. And so what happens though in 3.0 is instead of being able to only control the frequency domain, we can control the time domain and the frequency domain. So What that basically means is instead of it just being your linear channel plus a .1 or .2, .3, .4, .5, you could almost think of that as using, a half of megahertz and a half of megahertz and a half of megahertz, and that works out to, 19 megabits per second, and I won't bore you with the rest. That's how it was. In 3.0, we slice and dice that 6 megahertz however we want. Now, why would you slice and dice the 6 megahertz? What difference would it make? Why would we care to do that? What would be the need for that? Well, it depends on who you're trying to reach. If you're trying to reach a vehicle driving 70 miles down the highway, then you're going to use one subframe, one setting, and that would be an 8K FFT. Not that you care, but that's a subframe that we would use. If you're trying to transmit to a fixed device, you're going to use a different subframe, a 32K FFT. Again, we don't need to get into the weeds of what all that means, but you have to have different ways to slice and dice if you're going to different things. But what if I don't want to use all of my spectrum for a mobile or all of my spectrum for a fixed? You got to be able to slice it up, right? So we get into PLPs, physical layer pipes. And in those PLPs, you can also choose different levels of robustness for your signal. So what you're trying to work through is how far out that signal is going to be caught, what type of forward error correction are you going to have on that, as well as how much bandwidth are you going to be able to put through. Think of it as a negotiation between speed, robustness, distance, all sorts of efficiencies that are going to play in the mix. So what you're going to see when you see this screen is how we're slicing and dicing the signal, which takes place in the gateway. And so you've got 3 PLPs, and you can see see this blue line right here? That right there is one feed, one stream that's going out. And on the right, which you haven't seen me start this or you don't see it in the background, we'll show you, is a whole nother stream that's at 1 megabit per second. Okay? In 3.0, you can have any range. You're not limited to 19 megabits per second. You can get up in the 50s if you want, or down in the teens if you want, depending on how you want to modify that spectrum. Then you go from there to our exciter. This exciter right here is a exciter created, or that's by, we work with a company called Comark and Comark Digital Services. Comark works with this exciter, which is basically the brain of the transmission. So it goes to the transmitter and then it goes out. We won't really be going to the transmitter much more, so for simplicity, if it wasn't, bad enough already, I'm going to go ahead and close that out to simplify it for you. Then we get to this. This is another Triveni product. This is the stream scope. So even though I've got this on the broadcast side, what you're seeing here is a technical spec checking what's coming in. So we transmitted all of these over here, and now on the receive side, we want to validate that what we're receiving is actually quality. We want to see that we're getting all of the PLPs and all of the different streams of data and video that we want, and so we validate it here on the stream scope, and there's a number of ways we can look at that, poke around and see different things. Right now, what you're seeing is what's currently taking place. So you see the audio bits on the side. We've got 2 channels playing. Well, those 2 channels have multiple different audio feeds. Then on the left, you've got your video bit rate, which we've got an HD and an SD. And then on the bottom, you're going to also see things like we can click around some different screens. Closed captioning. I saw Aberdeen was in the room. You can see the different bits that are going through on the datacasting side as well. So you've heard enough from me. You're still going to hear more, but I'm going to bring up, and believe it or not, I'm bringing him up, and I'm staying up here so I can keep it simple. Yes. I'm going to bring up Ali Derneka. And Ali is a ATSC 3.0 solutions architect with Hewlett-Packard Enterprise. If you ever want to feel dull, just come and stand and talk with this guy for a little bit, because he is a genius and really does some magic. Why do we need to work with HPE? It's because all that you saw is what I'm able to do on a station level. But how do I work those different settings, market by market, at the national level? That's where Hewlett-Packard comes in, and this is why our secret phrase is edge to cloud infrastructure. Hewlett-Packard has taken what ARK was trying to build and made it to where it was all virtualized in the cloud, and we can now control our station at the bit level, modifying all those settings we just talked about from one national NOC, and we can enable our customer to do it themselves, where they don't have to call me and have me fumble around to get it done. And so I'm going to have Ali step behind the computer.
Thank you. It's a pleasure, really, to be with you in NRB. So as Josh said, we work together with ARK. We take this one further into having what I like to call it basically broadcast core network. Because this is from one place, you can control all your station. Station being edge, and your NOC, as Josh was saying, the broadcast core, is your cloud. So from one place, you will be able to control all your services, and basically, it's an enabler, right? In a datacasting use case, you need to dynamically create service, so it can go through into multiple stations at the same time, and as well, you want to destroy it, and another customer come and create this service. So what we have created, and this is simplified through a portal. Basically, you can control all these stations from this portal, and you can see me only doing stuff on this portal. And then we will navigate over other components and see how the service is being created and being broadcasted. So the first thing I'm doing is just I'm logging as ARK administrator. So we'll go to admin, and we go inside. So this is a portal that, together with ARK, we have designed. It's basically, it gives you a full picture or full view of all your services that has been activated in the stations. So we'll go a little bit through these tabs. So first one is basically just a monitoring view. It tells you what are the services and what is the status of every service. You can see here, I have one service that it's critical. Then what we have is basically a marketplace. This marketplace allows customers and as well ARK to create services. And you will see me log in through a customer and using the marketplace to activate services. But the most important here for ARK, being basically the host of all the network, is the system user interface. This is where he can control all his stations. And here you can see we have 10 stations being added. So station is the edge, basically. So here I have 10 edges being added into my core network, and I'm controlling all of them from one place. You can see here Chattanooga, College Station, Dallas, and so on. All these stations are here.
These happen to be the 10 stations that we're currently deploying. So what you're seeing here is the administrative portal where we set up all of our stations, and when we're complete with all 300 stations, we can have all 300 stations in here and enable the ability to modify all 300 stations from one place.
Exactly. Another important tab is basically the BVNO. This is the customers, this is the ARK customer. BVNO stands for Broadcast Virtual Network Operator. This is where a B2B will happen, and basically ARK will onboard these customers into the core network. So you can see here multiple BVNO already available here. We can browse through them. We can see here, for example, TBN as a customer has been already onboarded into this portal, and the Trilogy 5G. Another important station tab is basically the station assignment. This is where I define every customer to which station he has access. For example, here I'm checking, for example, Trilogy 5G, they have access to the Dallas station. Okay, and I can basically give them an actual bandwidth that they can allocate for their service. Here, 5 megabit has been allocated for Trilogy 5G. So when they activate their services, they cannot go beyond 5 megabit. Another important another important tab is basically how to allocate bitrate to the BVNO. And we can see here a number of customers that has been onboarded, and each one have a dedicated bitrate being provided to them. So we can see here, for example, a TBN has been allocated almost 18 megabit. So they can create services with 18 megabit on the station. User management, this is where they can create additional users into their BVNO. So, for example, here we see the list of users that has been created, and they can start logging to the portal and create service. So now, let me take one, we go into another menu. This is where basically the BVNO will log into the portal, and they will start activating services. So I will log in as TBN, and this is already saved, save some time. And I can see the services that has been already created. And this is a view only for TBN. So you can see they see only their services. They cannot see the services of Trilogy 5G, for example, or the services from ARK. They only see, this is a dedicated view for TBN. They see only their services. And here we can go to the marketplace and seeing the different services that has been already activated. So this view will give me the services that has been activated into, for example, the Dallas station. You can see here I have 3 services, TBN 1, 2, and 3 are already available. And if we go a little bit down, we can see the detail of the services. So far I have 2 services here are being active, right? So this is linear TV. So two channel has been active, and one is just configured into the system, but it's not activated. So what I will do here, I will start this service. Okay, we can see that the system has already been working. And in the background, there is a multiple component that it will go and activate this service on different component. And we will go see this component. But before this, let me go to the marketplace, and I want to create completely a new service. So I will create now a new service, and you can see how simplified we made it. It's through a number of clicks. I will create a live TV channel into the station. So I will call this as a TBN4. I have access to 2 stations. I will select the Dallas station. And then I have a component to select here, single component. Quality, you saw Josh talking about the different quality. Is it high bandwidth, low bandwidth, or mid bandwidth, right? It has to do with how much bitrate every quality will give for the service. For now, I will select basically a mid bandwidth. It's going to the route, and then I will select what is the high definition or lower or standard definition. What is the resolution of the channel? So for this service, I will select a standard definition. Here, I will select what is the input of this channel, because definitely you need to have a source coming into the station in order to create the channel. So I will select IP04, which is stand for the service that I'm creating. And now I will submit the request. And here, I'm just creating a metadata. It's just an information, so the back end, when I'm activating the channel, it will start and activating all the component that we will see.
And just to point out, what you're seeing here is already set up in our stations that have been deployed, but what you're seeing is actually in the lab. So that's why you're seeing some test things. We, ARK, because of the way the system is allowing us, we can choose what those different services are. So we can choose to offer a 4K, we can choose to offer a virtual reality, we could choose to offer an augmented reality. We can change all of the service options and make those available to our end customer.
Exactly. So now we can see a new entry on my service tab. It's available in any linear channel. So I will go ahead and start this channel. So I got a correct and proper feedback. So now I can go and show you basically the amount of services that has been already activated. Now I have activated one service, and then I have basically created another one. And we can see these services are already being added into this root MMT encoder. Not only here, we can see it available already on the gateway. We can see the services here. If we click on details, we see every service, what is the bitrate that has been allocated as well here. So we have used now around 4 services being active. We can see the services are completely now broadcasting into the gateway. So this is a linear TV. Let's go to the another type of service, which is the
Well,
datacasting.
let me show you on the receive side now. So this is the stream scope. Again, thank you, Triveni. And so you're seeing these are now new services being added, and you're seeing a lot more data going through. If we were to go to, let me go home here. So if you see it like this, these are different PLPs, and you can see the amount of capacity that we have. We've got 20.9, almost 21 megabits per second available here, 6.6 megabits here, 7.5 megabits here. Those things will all change and fluctuate based on the other settings that we talked about, because the trade-off as we're choosing mobile or fixed, as we're choosing higher forward error correction, as we're choosing to reach a greater amount or have a more robust signal, the trade-off is going to also be the amount of capacity that you have, which is why it's no longer just a fixed 19 megabits per second. So you're seeing now all of those video streams coming in, and I'll let you take back over.
Sure. So now I will go and basically activate another service. This time it's a datacasting. So what I will do, I will log out from the TBN account. I will log in as a Trilogy 5G account. And again, here I see only my service, and as you can see, I have no service being activated so far. So now I will take the first step, which is activating my service into the station. And this time I will select a datacasting service. So I will name it Smart City.
Smart city, you think about cities that are connected, how do they get data to the lights to tell them to turn the lights on? How do they get firmware updates to the utility meters, to an example that mentioned earlier? Well, they got to have connectivity, and they got to do it on a one-to-one case, or they can use a service like what we're doing and hit everybody at once.
So for this service, I have selected that I want to transmit this service at 2 megabit per second. So I am utilizing 2 megabit from the spectrum in the Dallas station. And now I will select the station, and this time you can see Trilogy have access to 3, but I will select the Dallas one, and this time I will select as well the medium bandwidth quality. And then I have to define, is it an NRT or carousel? Carousel means it's a loop. So when the files are being transmitted, the first file and then go to second, third, and then if the list of files has been ended, it will go back again and do another round of transmission. This can be used, for example, for a large file in order to allow many devices to, if the first iteration was they were not online, the second iteration they will be online and the file can be downloaded for them. So I will select a carousel kind of service, and then I will submit it. So, sorry about that.
Try one.
Yeah, I will just select, maybe I did not select.
High bandwidth.
Okay, exactly.
So what you saw there is because we, ARK, limited the amount of bandwidth that they could do in that specific frame that he couldn't do it.
So I select a different quality, the high bandwidth, and now it's successful. So I will go, I did. Okay. So I go to services. I see now my service has been available on my UI, and I can see it's going into the high bandwidth quality. So before I activate the service, I want to upload some files. So I will select this. I will select files that I need to upload. So I will select the 3 files. And I will upload them into the station.
Before we actually go and show you that transmission, I want to flip over to the end user side here. So we've got 2 different receive devices that you're seeing. There's one that's going to be a distance learning here in a bit, and then we've got a digicap box, which is a set-top box, and you're seeing the bandwidth of the actual linear channel here and different things there. But I want to show you the files. So you've got different files that are already here, and I can go ahead and clear these. So now there's no files there, okay? And so this way, when you see him start it and you see those files show up, you know that it's not just smoke and mirrors. We actually just transmitted this to that device.
So we need a little bit because the process has to grab the files from my PC here, take it all the way to the station, do some kind of publishing in order to be transmitted over the station. So this will take some time, especially we are, remote through a VPN connection. So this will take a little bit of maybe, and we can see now the file has been already published into the station, and now it's a time where we can go ahead and activate the service. So we have 3 files. Now I will go ahead and start this service. And then we can go now into the back end, into the route and the MMT, for example. We can see the service has been already created. And we can go as well into the element, see there is 3 files, the same 3 files that I have uploaded from my PC. Now they are available on the station, and they are now being broadcasted. You can see here that the transmission has started for the first file, and then it will go to the second and third one. And I have 2 megabit. So you can see now 1 file has been completed, the second file has been started. So it's a kind of loop. The files are being already now transmitted. And we can go into the device.
Let's go to stream scope first.
Yeah, we can go to the stream scope. So, and we can see here now, if we go a little bit here, we can see the new service being active, right? You can see how here we have a little bit of bump into the bit rate that it shows you that the service is now live, already live.
And you see it there on the bottom right, there's 3 files where it says data. That's those 3 files that are being done.
Exactly. We can go as well. This tool is amazing. It gives you a lot of details. So we can go to basically the multicast analysis. It gives you a lot of details, really deep technical details about your services. Now we can go to the receive side. And it will take maybe just a few times, so we can receive the files here. It will take some time, maybe. But we can see the bit rate has been as well increased when I start the datacasting service.
And when we talk about datacasting and what we're doing here, it's sometimes difficult for broadcasters to get out of the mindset of linear. So there are certain linear services that we can do in terms of data, but we view our business as really having the opportunity from a datacasting perspective in edge caching. So when you go to consume a Netflix movie, that Netflix movie lives on a server somewhere. And depending on your internet service provider, you go to ask for that file, and then your internet service provider goes and gets the file from where it's at. And so that process takes time, and sometimes you get the little buffering signal. And it's a costly thing for the ISP, it's a complicated thing for the OTT provider, and this is where CDNs, content delivery networks, come into play. And so from an edge caching standpoint, the CDN can live on that set-top box in the home of the end user. And the ISP would happily send that box to you to replace your current box that you have because it's going to free up some 65% of their capacity. And the CDN would happily live inside that home because now it's going to be a much more efficient way for the end user to be able to access that data because they're accessing that data at the speed of their local area network, which is, their Wi-Fi in their home, instead of having to access it by the time it takes to ask the ISP and then to go get it from somewhere else.
So for this, I will activate the CDN services.
So we have now another customer that we've set up as a CDN. So who would be a CDN? Well, Amazon has their own CDN. Netflix has a CDN. They call it Open Connect. I imagine that there's probably more CDNs being used than what we realize because, if you're like me, I just go ask for the file. I don't know where that file lives. Well, it lives on a CDN most likely. And what the CDN allows is so that if I go to ask for a given file and that file isn't available, first the CDN will say, where's the closest node, where's the closest server that file lives? If that lives in the home, then it will say, yeah, pull it from there. If it doesn't live in the home, it's going to say pull it from whatever the closest data center is. That's where the CDN component comes in, and a CDN can just as easily be my customer. I can move their CDN closer to the end user. And so we'll see a CDN here. In this case, we've got PureFlix. They use CDNs all the time, I'm sure, to host their movies. And so we have the CDN has gone in and started this service.
Exactly. So now I started the CDN service. We can go see on the route MMT encoder that I have a new service being already created. This is a CDN PureFlex. And I can see the amount of files that are being basically ingested into the station, and at the same time will start transmitted. So we have here around, 20 files already that has been identified that these are files that need to be offloaded. So CDN will basically offload these files into the ATSC3, and in this case, the process of ATSC will transmit this into the ATSC Datacasting service. And we can see here, these are the multiple files, and now it is being transmitted one by one. So this is another, as well, example of how Datacasting and how this core network, broadcast core network, enable basically a new use case. So it's much more than just TV. Here we are using the bits for very important use case like CDN offload. Okay, now we can go see if we can get the file. So here we see the files are already being received by the receiver, and we can, for example, here click the link and view the file. This is a file being transmitted over ATSC. It's not basically a live TV.
The CDN can also create a new linear channel. So you can have a ministry that chooses to broadcast all of their files, everything they've ever created, and then they can create their own linear channel from all of those files that live inside the device, inside the CDN of that set-top box. That's just one, small opportunity.
Exactly. Another use case is about private service, and you can see here the files are keeping download on the receiver, because it's being transmitted by the station one after the other. Now we go to basically another type of service. This is distance learning. And
so in this case, we're working with a company called SpectraRep. SpectraRep is, you'll be seeing a press release actually that we just signed an agreement with them to basically work with them across the country with our different stations. They're going to be doing some stuff in these first 10 markets. And SpectraRep is also likely going to be how we service the Dallas Independent School District with Trilogy. And so there's a lot of opportunity here. There's different distance learning service providers, but with SpectraRep, their service it can be done a couple different ways. In this particular example, we're logging in as a teacher to serve our students. So I'm teacher, Sister Joe at, the 8th grade math class, right? And she can then click on that math class. She can go to all students, or she can create a new student, and then she can send the students what files is desired. So you see, these are files that were uploaded as distance learning files. They can be videos, they can be PDFs, they can be whatever the teacher wants. The teacher controls it because they have their own login here at the station. Then on top of that, they send out this device, and we have over here another device that the student gets. The student logs in, and we've got a set login here already saved, and this is that student. And so if I click on this folder here, we've got some 10 files in the history lessons, and I can't delete these. All I can do is download them or open them up as a student. So we've got this American history lesson. They can open it up, they can do their schoolwork, and then, of course, turn it in and move on, right? So that's the student, this is the student side. And if I were to go on to the teacher side, and let me see, so I'm logging back in as the teacher, and I'm going to go to the history, I'm going to look at the all students. We've got these files here. If I were to, let's look this American Leaders and Statesmen worksheet, right? You see this file right here? I'm going to come back over here. I'm going to look into the history folder, and I'm seeing that file already exists, the American Leaders and Statesmen worksheet. See that there? Well, the teacher can choose to delete that file because they no longer want that to be out. So the teacher just deleted it, and in a moment you're going to see this box no longer have that file in the folder. And at the same time, the teacher can choose to add a whole new batch of files. So I'm going to add new folders here, or new files here. And I'm just going to drag a whole bunch of things from this folder. So now those files are there. Now he hasn't activated this service yet, but you can see we've already deleted this file on the teacher end, but the student hasn't had it deleted, and we just added a whole bunch of files that haven't shown up, but the service hasn't been started. So I'm going to let you go in and start the service.
Yeah. Okay, now I will log in as Spectra Rep.
Other way.
Oh, sorry.
Well, yeah.
No, not here. Okay. I think it's active. So we'll go as Spectra Rep. So I will log in to my service, to my BVNO instance. And I can go to this one. We call it a private service, basically because it's an implementation only for distance learning. But as well, we can control it from one place, and we can see the service is already started. So it is already online, and basically now we can see the files being already transmitted over this service.
An exciting thing about it is, one of the difficulties with distance learning is trying to get teachers to learn anew or to have a new process that they go through to get students specific files. That's a difficult thing. So what we're demonstrating here is just showing one application. But it's already set up that if the school uses Google Classroom, then they don't have to set up or go through this login. The teacher would just go to their Google Classroom and they'd create, instead of Susie getting her files this way, Susie gets her files through the ARK casting, right? And the same thing, if they use Canvas or whatever their learning management system is, the LMS, that will implement into the distance learning service.
Exactly. So from one place, I'm going back to being in ARK. So I can see all services that has been activated into my network. So you can see the CDN offload, and this is a private service. I can go and see basically the different service that has been activated. Oh, maybe I deleted. And then the linear service, I can see the
Oh.
Yeah, I can see all the services being available. And the nice thing as well, we have implemented a kind of billing. So every user, and here, for example, the ARK can see all the spectrums that has been utilized, each one, what is basically the bill for each of the BVNO. So it gives a full view of basically the utilization on my network.
Can we give Ali a big round of applause?
Thank you, appreciate it. Thank you. Hopefully it was good.
Yeah.
Thank you.
So I know that we got really deep into the weeds here, but we wanted to show you a demonstration, and you can't show a technical demonstration without being technical, right? There's going to be some level of technicality here. And so that's what this was, and I'm really excited about the opportunities that are here because of this, and I hope that those in the room who are participants in broadcast, in content, and looking for new innovative ways to reach people, that you recognize the tremendous opportunity that we have in not only the standard, but in this platform. And so I want to thank HPE because they provide that opportunity. Everything you just saw, that was pretty complicated for one station. And they've made that possible for us to do that across the entire nation with one portal, doing all of that good stuff in the background at each and every one of those stations. So very appreciative for them. Really appreciative for Trilogy 5G and TBN and their forward thinking. And I just want to challenge us to continue to innovate so that we can reach our world with this message that we say is important. And if it is important, we should be willing to do everything we can to reach everybody we can. So with that, I'm going to call Lee Miller back up. I want to thank you for participating. I'm going to put back up on the screen this QR code for you to register for the TV. Again, the key word is, or key phrase is edge to cloud infrastructure in honor of HPE and their solution.
All right. Thank you, Josh. And folks, when I first heard about this 12 years ago, there are lots of smarts that have gone into this over many years. And I want to thank guys like Mark Aiken and Josh and Randy and Madeline and all of those that have put, there's got, I don't know how many, do you keep track of the hours? Oh, I can't imagine the number of hours to bring this to fruition. So I want to thank ARK, HPE, and TBN Trilogy for what they're doing to bring this to the marketplace and to the Christian world to help us to share the message. And also, thanks from the Advanced Television Broadcasting Alliance. We'll be at NAB. Be sure and see us there. Be sure and catch Madeline Nolan with her presentation at 10:15 in the morning in the NRB Talks session on the exhibit floor. And that's all I have.